Hello and welcome to this video. In this video, I'm going to demonstrate how to do PIAAC analysis using the public use file data, and we'll be producing a regression-based analysis where the plausible values are the dependent variables. You can see in this R script, we have developed an overall rationale for this script. And if you go to the link here, you will see this open access Google Doc where myself and my colleague, Kai Da, provide a rationale for what exactly we are doing. And all the formulas that we are applying when we do the regression-based analysis. So let's get started. For this example, we're using adult data from Kazakhstan and focusing on predicting literacy of non-secondary qualified adults or non-post-secondary school qualified adults based on highest qualification, gender, age, native tongue, and extent of habitual reading. When we do this analysis, we need to carefully prepare all our folders and all our files. So you need to make your working directory, which will be a folder on your computer, and you need to place all the data there. In this case, you need to place all the different files for each country, all the CSV files, and download them and put them in that working directory. You also need to download the international codebook and place that in your working directory as well. Here's the name of the codebook here. I'm working on a Mac, and this is how I set my working directory, like this. If you're on a PC, you will set it up another way. Also, you can use session, set working directory, and choose directory as well to choose the folder that all your files are in. Let's start with step one. Of course, we should clear our global environment here. We can run this code to do that. You need to install the EdSurvey package, so run that if you need to, and also load it in your library. You can see that mine is already loaded here. Use the EdSurvey package and the read PIAAC function. Use your working directory here as the local folder and extract Kazakhstan. This may take a few seconds. You can see the result when it comes up here. The structure of the data is a list in this case. You can see this involves a whole lot of different pieces of data about Kazakhstan to do the analysis. Let's focus on subsetting the data only for those persons, those adults that have non-secondary, non-higher education qualifications. So this is ISCED 4 and below. We use the subset function on the CAS dataset. We use this type of pipe function, and then the variable here is B_Q01A, which is the qualification. We run that code. Next, we have the age grouping variable. It's currently a factor, but we want it to be a standardized variable. So first, we change it to a factor, from a factor to a numeric vector, and then we change it to a standardized or Z-transformed variable. Let's also change to numeric and also change to the scale score or standardized variable for the reading at home variable. Let's also change gender and native language to numeric values. We should always check the outcome. Here we have gender as 1 and 2. You can check that coding. And native tongue is 0, 1, and 9. So 9 is actually missing. So this is currently coded incorrectly. To recode this variable, let's use the EdSurvey function recode. You can see how we're recoding 9s to NA. NA means missing. Run the code, and we see that we've resolved the problem. Now, for the qualification, which is B_Q01A, we want to provide 2 levels in this example. We're going to choose low and moderate levels of qualification for these individuals. So we use the same recode function from the EdSurvey package. We check our data. We see that we've got low and moderate only. Perfect. Now we can run the analysis. The analysis is done on complete cases. We use here the EdSurvey package linear model function. The outcome is literacy, LIT, gender, age group, native language, qualification level, low or moderate here in this case, and reading at home are predictors in the model. The data is CAS. We're using the jackknife method to manage the estimation of the standard errors. And also we're using 10 plausible values here to manage the imputations or the variance due to imputations. This also is part of the estimating these standard errors of each coefficient in the model. We can run the model, generate a summary with the same arguments. Shouldn't take too long. Okay, and we produce our output. We get an output, basic output, which includes the formula, the basic or main weighting variable, the approach for managing variance or standard errors, the number of jackknife replicates, the number of plausible values, the number of the full data in the data set, and the number of used data. This is complete cases, is 1841. For the coefficients, we get an intercept. For literacy, this is on a global scale. And we see the effect of the different predictors on the model, or on the outcome. We get all the different coefficients here. We get the adjusted standard errors. So with the coefficient and the standard errors, we then compute the t value, which is coefficient divided by standard error. To work out the p-value, we need to take the t-value and the degrees of freedom. Now, the degrees of freedom are slightly adjusted for each coefficient. So when we take that data, we can produce the important level of statistical significance for each coefficient. I've annotated the example here just for the current result, but you can delete that. Also, I've just given some code here using the stats base function and the stats package with the P and T function. I'm just replicating here the t value, the degrees of freedom, and the estimated p-value here. We can see it's 0.63329, 0.63328. to 0.366, 63 to 83. Exactly the same. Okay. So that's how you use the EdSurvey package. Now, one of the limitations of using the EdSurvey package is that you need to prepare the data using the EdSurvey functions. This can be a little problematic for those who are used to using base R or would like to run the analysis using base R. Therefore, what my colleague and I have done is created some guidelines for using base R and replicating the current results above. So let's, I guess, start again and use base R to replicate the same results above. Again, we have the codebook that you need to download and put into your working directory, the folder on your computer that you're linking this session to. Also, this time, let's use the SPSS.sav data for each country. You can download that and put it into your working directory. We set the working directory. It should come up here. Let's start by deleting or removing what we have in the global environment. Here I'm using the Pacman package. This code here downloads and installs the Pacman package if you need it. Even if I run that code, I don't need it because I've already got it. Same here, we use the Pacman package and payload function. Here we download and install these packages if we need them. Let's get the Kazakhstan data. This might take a while. It should populate as a data frame this time in the global environment. We can check its dimensions. It's the same. Let's just explore the data. We can explore the first plausible value. We can see, based on its summary and its structure, that it's a numeric value and it can be easily managed. Likewise, all the other plausible values. Let's look at the independent variables in the model. These are the education levels. It's a factor with 15 levels, the ISCED qualification levels. Let's subset that later. Gender is currently a factor. We can see, so let's change it to a numeric. Let's now move on to age group. It's a factor. Let's also change it to numeric and check the results. Here, this is native language, whether or not the survey was conducted in the person's native language or not. We have quite a few missing data points as before. Let's recode it as numeric and also check on the missing data points. No problem, it's now numeric with NAs as missing, which is what we want. NA is missing in R. Okay, now let's move to recoding the reading at home variable. And there are 6 levels. Let's check the final weight. Okay, this looks like a numeric value. It is, and it has a mean and a standard deviation, no problem. Let's check the replicate weights, the jackknife replicate weights for adjusting our standard errors of the coefficients. These are all numeric. And we also have a sequence variable, which can be helpful. Let's move now to data manipulation. Let's use the dplyr packages select function to only select the variables we need for this analysis. As I said before, we need to recode and subset the qualification variable. So here we are subsetting the variable or the data set only with those who have lower levels and moderate levels of qualification. Here we are changed using the if-else function, and we are recoding for low and moderate levels of qualifications. Now it says conduct scaling here. This means just standardizing the variables. In this case, we're creating a new variable, reading at home scaled. Here we're creating another variable, the age groups scaled. We can only use complete cases only. We can check. We have 1841 for the complete cases, which replicates what we did before in the EdSurvey package. We can quickly check the variables. No problem. Check them again if you like. Let's now move into establishing the series of plausible values to generate the mean coefficients for the regression equation. So let's work out what columns the plausible values are for literacy. So here we create a list of names. The column names from column 7 to 16 are the names for the plausible values, PV lit 1 to PV lit 10. This is now a vector, and we use this in the lapply function as we loop through each plausible value to create the average coefficients. You can run this code here. Here we get the averages for the coefficients in the final model, based on the averages from 10 regression equations using each individual plausible value. However, because of the multi-stage sampling design, we need to account for the variance due to sampling, and we need to also account for the variance due to imputation, which is the generation of plausible values. So here we are creating functions due to sampling and PVs. Here are the functions here. Let's also generate the row names for the jackknife replicate weights. Here they are here. We're going to use that a little bit lower. Here we generate the functions. This is the function to generate the variance due to sampling, sigma S. This is the function to generate the variance due to imputations or plausible values. We're going to use these to adjust our standard errors for our coefficients. This is based on equation 1, and this is based on equation 2 in our rationale. Okay, here we are running each model. We're running models multiple times for each plausible value. We also adjust for the Welch-Satterthwaite degrees of freedom formula for each plausible value as well. So here we're running the model for plausible value 1. This is for the first plausible value here. So we run the model and get the results. Now, at each step, we are generating the adjustment to the degrees of freedom. For this first step, let's define the plausible value 1 as the set of coefficients. You can see here. You see 80 coefficients, 80 sets of coefficients for each jackknife replicate. Of course, in that formula, we are also using the final weight, which is this here is based on the results for the coefficients for plausible value 1. Here is the function that I wrote for you to determine the main part of the equation for the degrees of freedom adjustment. This is here. Here is the function. So we can simply move through each plausible value and generate the adjusted degrees of freedom here, the Welch-Saterth weight adjusted degrees of freedom here for plausible value 2. Let's also run the model again using the 80 jackknife replicates and the 80 jackknife replicate coefficients and the plausible value 2 related coefficients for the models, and also, well, this is actually for plausible value 3. Let's move again to plausible value 4, again to plausible value 5. You can see the adjustments that I'm making here, PV5, PV5, PV5 again, sigma PV5, PV set 5, and so on. Okay, now we're up to plausible value 9. Remember, this is using the 80 jackknife replicate coefficients and the baseline for the coefficients for the plausible value 9. And also we're doing the degrees of freedom adjustment as well. This is the last one for plausible value 10. All right, moving into our latter steps. Here we're calculating the variance due to imputations, and this will be in accordance with equation 1. We simply find the means. Yeah. Let's finish it off here. Calculating the variance due to sampling, and now the variance due to both imputations and sampling. Finally, we apply the square root to that total, and this gives us our vector of standard errors to report. Here we calculate the t-values, which is simply the mean of the all the coefficients for the plausible values divided by that adjusted standard error. Okay, now we are finding the mean of the degrees of freedom. Let's find that. This is in accordance with equation 4. We also need to provide a final adjustment to, using the Johnson-Rust correction. This is in accordance with equation 5. Here I wrote the function, and you can just apply that here. So we generate a vector of adjusted degrees of freedoms. We're using the same formula above here to generate the p-values for each coefficient. Let's collate everything. We have the mean plausible values from all, the mean coefficients from all plausible values, the adjusted standard errors adjusted for both sampling and imputation or plausible values, or adjusted for both sampling and imputations / plausible values. The t-values, which is simply the mean coefficients divided by the standard errors. The degrees of freedom are now completely adjusted. So with the t-values and the adjusted degrees of freedom, we get the final p-values. We collate everything together and report it. Here are the results here. And as you can see, they are extremely, extremely close, almost to 3 decimal places. For the p-values, obviously the coefficients are exactly the same. We hope that this helps you in your journey for analyzing PIAAC data. If you have any questions, you can email us or make a comment in the video. Thank you so much.